Hello, welcome to Old School Science Demonstrations. I'm your host, Stephen Rakusik. Today we're looking at Bernoulli's principle, and this one's called Bernoulli's ball. Now what you'll notice on the website, we're going to have about 10 or so videos that deal with Bernoulli's principle, in which each one of those will have a demo card. We'll also have a lesson plan with more description about that principle, okay? Bernoulli's principle, simply stated, would be an increase in the velocity of a fluid results in a decrease in pressure, okay? This would explain, for example, why airplanes fly. And in one of the videos, I'll actually show a little airplane and describe how that works too. For this one here, we're looking at a classic science demonstration in which you can float a ball above a hairdryer. Okay. Okay, in this case, it's a ping pong ball, okay? Now, one of the questions I always ask the kids is it being pushed out or pulled up? Okay, I'd ask that question, and usually most kids will say it's being pushed out. Okay. Which, if you look at it, it makes sense. You know, it's being pushed out, it's being pushed up. But then I show them the same thing, but I put the ball out to the side. Then it kind of throws them off a little bit, because if it was being pushed out, it should just fall off before I shut it out, the hairdryer off. What's actually happening, if the hairdryer is sitting like this, the air is coming up, hitting the ball. It's actually speeding up to get around the outside of the ball. So the air is actually moving the fastest, the greatest velocity on top of the ball, okay? So imagine this, if I put the air like this, and I turn it on, we have air traveling all around it. We also have the air hitting it and then traveling around the ball too. It has to move a greater distance. If the air is hitting here and going up around the ball, it has to go then faster to get around the ball to be at the top at the same time as the rest of the air around it, okay? In that case, it's moving a lot faster up here, results in a decrease in pressure. Now how we can show this, when I turn it on this time, I'm actually going to put my hand above it, and I'm going to disturb the air above it without touching the ball. You'll notice it go down. And it's no different than a turbulence in a plane. So if a plane is going along in the air, and there's some disturbance in the air above the wing, and we have a little loss in lift, the plane can actually drop a little bit or kind of move around a little bit in the air. So I'm going to go ahead and try this once. You'll notice I'm going to put my hand above it and push it down without touching it, because I'm disturbing that air going above it. You notice there just happened. You'll notice I put my hand above it, it really starts to move around, start to jitter a little bit. I'm actually disturbing that air and slowing it down above it too. So the lift is being, in this case, eliminated. Now what's kind of cool about this is you actually can beef this up a little bit and then try it with a leaf blower. And I guarantee the kids will like this. Okay, I'm going to go ahead and put this on. Now one disadvantage in probably many of the classrooms and also in here is we have height restrictions. So if you remember before, when I placed my hand above it, I was able to disturb that air and cause the ball to drop. The same thing will happen here. So if you have a low ceiling, let's say in your classroom, you notice the ball will drop around and kind of fall, just like this one did here. It'll bounce around. So it actually works better outside, or in a gym, works fantastic too. We'll try it here though, and we'll also then try it in a gym also to show you the slight difference there. I'm going to go ahead and try it, and it's going to be kind of noisy. I'll put the ball on here. I'm also going to put my hand above it, and you'll see how it comes down with that disturbance too. I'm going to start with this one right here, and we'll put this on there. You might see a little dust too. We'll find out here. You'll notice the ball is floating. Put my hand above it. I noticed when it was balls way out to the side, it really proves that it's not being pushed out, because if it was being pushed out, it would just fall. Actually, the air is going around it, and it's going around, and it's speeding up. As a result, there's less pressure up on top. Now, if you get it out too far, it eventually will drop, and there's enough of a disturbance, which I'll show you that right now. So try it again, and this time we're going to take and put it out a little bit too far, and eventually it'll fall off to the side. We'll start this up again. Put it out to the side. But you do notice it actually goes out quite a ways, which is pretty cool. You can also try this with balls that are a little bit lighter, and you'll find a perfect ball for you. And what's kind of cool about these, you actually can go like to a gym and shoot baskets too. And I guarantee the kids really like that too. We'll try this one once. You'll notice too, when I put this up in the air, the studio here is a little, it's pretty tall, but there's a lot of light racks and so forth, and it really disturbs the air, so we'll see it bouncing up and down a lot. We'll see if we can get it to work here a little bit though. Again, I hope you enjoyed this demonstration of Bernoulli's principle, and make sure you check out the lesson plans and the materials list on the website.